Welcome to Chemistry channel. Today's session is about revision equations as per 2023 syllabus ICSE class 10 for the chapter 12, that is organic chemistry. Okay, let's start without wasting the time. Alkanes general formula is CnH2n plus 2. Write molecular and structural formula of methane and ethane. This is strictly as per your 2023 syllabus. Okay, put the value. Methane means carbon number 1, so you will get CH4. This is the molecular formula. C2H6 will be ethane molecular formula. Structural formula, for every carbon you write 4 hydrogen atoms. So that is structural formula of methane. Ethane, you write carbon-carbon single bond, and then remaining bonds you will write hydrogen atoms like this. Next comes laboratory preparation. Write balanced chemical equation for lab preparation of following by decarboxylation reaction using soda lime and sodium salt of carboxylic acid. Very important, soda lime and sodium salt of carboxylic acid. This is the only method of preparation both for methane and ethane we are learning. It's called as decarboxylation reaction because we are removing carbon dioxide in the form of carbonate. Okay, so therefore it's called as decarboxylation. What is soda lime? Soda means caustic soda, that is sodium hydroxide. Lime means quicklime, that is calcium oxide. We are not taking only sodium hydroxide, we are taking the mixture of sodium hydroxide and calcium oxide. The reason being, sodium hydroxide is deliquescent in nature. When you use calcium oxide, it will reduce the deliquescent nature of sodium hydroxide. Okay, for methane, what are the starting materials? Soda lime is common for both. Sodium salt of carboxylic acid, here for methane you will take sodium acetate, CH3COO-Na. How do you get sodium acetate? Okay, when you take acetic acid, we know this, CH3COOH, and you make it react with a base, sodium hydroxide, you will get a salt, CH3COONA. This is a salt plus water you will get. Okay, but we are taking only sodium acetate. Its IUPAC name is what? Sodium ethanoate. Okay, this part is not necessary for you, just for your information I gave this. Plus soda lime is NaOH. Only sodium hydroxide reacts, quicklime is simply there. What happens here? Decarboxylation, remove sodium carbonate from this, sodium carbonate like this. See, there are 2 sodium atoms, 1 carbon atom, 3 oxygen atoms. So what is this? Sodium carbonate, Na2CO3, plus what is left? CH3 here and H here, CH4. What is CH4? Methane. That's what we are preparing. Okay, next you want ethane, means what you have to do? You have to put one CH2 group between CH3 and COONA. Right, so that is what? Sodium propanoate. Here 2 carbons, so ethanoate, 3 carbons, CH3 CH2 COONA. Now how do you get this one? Simply you take propanoic acid, CH3 CH2 COOH, react with NaOH, you will get this sodium propanoate. Next you react it with sodium hydroxide in presence of calcium oxide, or what is this? Soda lime together. Remove the sodium carbonate once again from this, so therefore it is removing carbon dioxide in the form of carbonate. So this is decarboxylation. What is left? Okay, Na2CO3 plus CH3 means what? C2H6, that is ethane. This is also gas, this is also gas. All methane, ethane, ethene, ethyne, all of these are gases. Okay, remember all of them are collected by downward displacement of water method. They are not soluble in water. Okay, next, is it balanced? Yes, they are already balanced. Come to chemical properties of alkanes. Balanced equation for complete combustion of. There are two things you can see here, complete and incomplete. Complete combustion, what happens? Any hydrocarbon you take, any hydrocarbon. What is hydrocarbon? Hydrogen and carbon containing substance. Alkanes, alkenes, alkynes. When it undergoes complete combustion, they will always give you CO2 and H2O. Even alcohols also give you CO2 and H2O. What happens when they undergo incomplete combustion? They will give carbon monoxide and water, not carbon dioxide. That's the difference. Carbon monoxide is poisonous. Carbon dioxide is non-poisonous. Okay, balanced equation for complete combustion of methane. Methane is CH4 plus O2 gives you CO2 plus H2O. This is the skeletal equation. Balance the equation for complete combustion of this hydrogen 4 here, 2 here, so write 2H2O. Oxygen 2 plus 2 4, so write 2 here. So this is balanced. Next, ethane C2H6 plus O2 yields CO2 plus H2O. Try to balance this. Okay, this is a little difficult. Check here. You will get the answer. I will directly write it. 2, 7, 4, 6. Okay, you can pause the video before this and try to balance it. Okay, this is the balanced equation. Next, for incomplete combustion, CH4 plus O2 yields CO plus H2O. Again, 4 hydrogens here, so write 2. Oxygen 2 here, so this is 2. That's it, right? Next, for ethane, C2H6 plus O2 yields CO and H2O. Try to balance this. I will write the balanced equation here. 2, 5, 4, 6. 4, 6. Okay, this is the balanced equation. Next, what type of reactions alkanes will undergo? It will undergo substitution reactions. Substitution means what? Hydrogen is replaced by chlorine, because we are learning only chlorination. Okay, so hydrogen is replaced by chlorine. And what is given here? Balanced equations with product names, that is IUPAC. Let's try to write it. Complete methane with chlorine, complete, because methane has 4 hydrogens. Okay, every hydrogen is replaced, plus Cl2 and minus HCl, means there are 2 chlorine atoms. One chlorine will replace one of the hydrogens. That hydrogen will combine with another chlorine and go as HCl. So HCl is actually product side, therefore I am writing it as minus. What you are getting here? CH3Cl. Next, it will not stop at this, it will continue until all the hydrogens are replaced. CH2, Cl2 plus Cl2 you do minus HCl, CH, Cl3. I will write here plus Cl2 minus HCl, not CH, CCl4. You will get CCl4. Common name of CCl4 is carbon tetrachloride. CHCl3 is chloroform. This is dichloromethane. This is chloromethane. Chloromethane. So IUPAC name they have asked. Chloromethane. This is dichloromethane. This is trichloromethane. This is tetrachloromethane. Okay. Similarly, you can try to balance the chlorine reaction with ethane. Okay, we'll write here C2H6. So here you will come across 6 steps because every hydrogen has to replace. Okay, so you can write it C2H4Cl2, one more chlorine molecule, remove HCl, C2H3Cl3, one more chlorine molecule, remove HCl, C2H2Cl4. Okay, I will write it here. One more chlorine molecule, remove HCl, C2HCl5. One more chlorine molecule, remove HCl, C2Cl6. Okay, try to name the IUPAC naming of these molecules. Cl means chloroethane, right? Now chlorine here. So this chlorine is on the same carbon. This chlorine is on the same carbon. So the structure will be like this. CH3ClClH. Okay, this is the structural formula. So what you will write? 1,1 dichloroethane, right? This will be what? All the three are on the same carbon. So 1,1,1 trichloroethane. This 1,1,1 and you can write or may not write because it doesn't matter whether it is on this carbon or another carbon. But when it comes to Cl4, then it will be different. Okay, I will write its structure here. Check here. Carbon, already one carbon, all hydrogens are replaced, 3Cl. Therefore, one more Cl will be from another carbon. So, what is the name of this molecule? Right? 1,1,1,2 tetrachloroethane. Correct? 1,1,1. So, number should be given 1 to this, second to this. So, 1,1,1,2 tetrachloroethane. So similarly, you can try for this. One more hydrogen is replaced by chlorine. So it will be 1,1,1,2,2. How many chlorine? 5. So pentachloroethane. Last one you can predict 1,1,1,2,2,2 hexachloroethane. These are all IUPAC names. IUPAC names are also important. Next, this is all about alkenes. Alkenes. See, alkenes, what reactions you studied? Only substitution. They do not undergo addition. Alkenes are what? Saturated hydrocarbons. Saturated hydrocarbons will undergo only addition reaction. Sorry, substitution reactions, not addition. Okay. Come to alkenes. Alkenes and alkynes. They are categorized as unsaturated hydrocarbons. Okay, general formula of alkenes: CnH2n. Okay, write molecular and structural formula of ethene and propene. The first member of alkene is ethene. There is no methane. Ethene, what is the molecular formula? C2H4. Propene, C3H6. Structure you write, because it is alkene, double bond should be there between carbon and carbon. So then how many hydrogens on this? 2 hydrogens. On this 2 hydrogens. So this is the structural formula of ethene. Propene, again you can write this double bond here or between these 2 carbons. It will be same only. So here 3 carbons, 3 bonds, here 4th bond, here only 1 bond is there, make another 3 bonds, hydrogen, hydrogen, hydrogen. So this is the structural formula of propene. Come to the laboratory preparation of ethene. You have to write with conditions and names: dehydration of ethanol or ethyl alcohol. Okay, to do dehydration. Dehydration means what? Removal of water. People say dehydrated. I am dehydrated. I need water. Right? The body dehydrated means lack of water. Dehydration of ethanol. Ethanol contains water molecule, not water molecule, elements which can form water, that is hydrogen and oxygen. So we have to use a dehydrating agent. So dehydrating agent, we know what is it? Concentrated sulfuric acid, or we can also use alumina. Okay, we can also use alumina. Now take the alcohol ethanol, C. I will write it like this: H OH H H H. Okay, why? Because it will be easy for me to show the removal of water molecule. Concentrated H2SO4 around 170 degrees Celsius. What happens here? The H and OH is removed. H and OH is removed as water molecule. So a new bond will form between carbon and carbon. So an alkene will form, that is ethene. C double bond C, H2 H2 plus H2O. You need not to write these structures and all. I'm writing it so that you can understand it. Okay, you can simply write CH3 CH2OH for ethanol. For alkene, ethene, you can write C2H4. Water, you can write H2O. Instead of this, you can also show the alumina. Instead of concentrated sulfuric acid, you can also write the alumina. That is also correct. Another method is what? Dehydrohalogenation. Dehydro. Before that, for alumina, the temperature is not same. You will use the temperature 350 degrees Celsius. For concentrated sulfuric acid, 170 degrees Celsius. Okay, dehydrohalogenation. Dehydrohalogenation. Halogen means FClBr halogen group. So you are removing water as well as you are removing the halogens. Therefore, it is called as dehydrohalogenation of what? Bromoethane. Bromoethane. What is the formula? C2H5Br. Okay. What I will do, I will write the structure so that you can understand how the halogen and water is removed. Okay. HBr H. So this is bromoethane. Bromine can be on any carbon. Now, to do dehydrohalogenation, what is the reagent we are using? Potassium hydroxide. But this is not aqueous solution. This is alcoholic solution, hot and concentrated. These all conditions you have to write. Alcoholic means what? KOH dissolved in alcohol. Aqueous means it is dissolved in water. So here, because the organic compounds do not dissolve in water, if you take potassium hydroxide in water, you will do different kind of reaction. This reaction will not happen. Therefore, KOH in alcohol, hot and concentrated. So potassium hydroxide. So K plus OH minus. I'm just showing you how it is going to happen. So OH minus will take away hydrogen and form what? H plus it will take. So what it will form? Water. K plus will take Br minus. So what it is forming? KBr. So a new bond will form between the carbon and carbon to compensate the loss of atoms. Right? So what is the products? What are the products? CH2 double bond CH2 plus H2O plus KBr. So if you check, I think it is already balanced, right? Very nice. So next, laboratory preparation of ethene is done. What are the chemical properties it is having with conditions? As I already told you, unsaturated hydrocarbons, alkenes and alkynes, they undergo only addition reactions. They do not undergo substitution reaction. Okay, so addition reaction, we have different molecules adding here. So based on that, we call it as different names. Addition of hydrogen, so that's called as catalytic hydrogenation. Why catalytic hydrogenation? Because we are using a catalyst here. To ethene, So write here CH2 double bond CH2. What you are adding? Hydrogen. So H2. Catalyst what we are using commonly? Nickel. Okay, temperature is around 300 degrees Celsius. Okay, so the catalyst can also be palladium or platinum or nickel. Okay, any catalyst. Now what happens? This hydrogen will undergo it will go and add to the double bond. One hydrogen will go to this carbon, another hydrogen will go to this carbon, so this will become a single bond, and H2 will become H3, CH3, CH3. What is this? Ethene. So ethene you are converting into ethane, right? Yes. So unsaturated compound can become saturated. So instead of like this, they can ask you how do you convert ethene to ethene? Write a balanced chemical reaction. Okay. Next. Addition of halogens. So you are adding the halogen across the double bond. You can call it as halogenation. Particularly chlorine means chlorination, bromine means bromination. Everything is same, right? Ethene you take CH2 double bond CH2. Chlorine you add. Okay, but here what is the condition? You have to take the organic solvent carbon tetrachloride CCl4. Okay, next chlorine will add across the double bond. It will form CHCl, sorry, CH2Cl, CH2Cl. One chlorine will go to this carbon, another chlorine will go to this carbon. IUPAC name of this is what? 1,2 dichloroethane. 1,2 dichloroethane. Similarly, exactly same way you can do the bromination. CH2 double bond CH2 plus Br2 in CCl4. You will get CH2 Br, one Br here, another Br here. What is the name of this? 1,2 dibromoethane. Okay, next. Alkynes. General formula CnH2n-2. Molecular formula of ethyne and propine, and their structural formula: ethyne is C2H2, propine is C3H4. Okay, so alkyne means there will be a triple bond, so write carbon carbon triple bond, one hydrogen on this carbon, another here. Propine 1 2 3, and there should be one triple bond between carbon and carbon. You can write here or here. So one hydrogen, this carbon already has 4 bonds, so this carbon need to give 3 hydrogens. Okay, so these are the structural and molecular formula of ethyne and propine. Come to laboratory preparation of ethyne. Ethyne common name is acetylene. Sometimes they may ask you the common names as well. Okay, water with calcium carbide, very important. Carbide, if you remember what I'm telling you now, you'll not have confusion. Carbide is what? C2 minus 2. What is the structure of this? C1 2 3. C triple bond C, 1 minus here, 1 minus here. Okay, this is the anion. Calcium carbide, how you will write? CaC2. Means minus minus satisfied by positive charge of calcium. 2 positive charges of calcium. Plus what you are adding? Water. So it is waiting for hydrogens, carbon with negative charge. So it will take away the proton from the water. So it will form what? HC123CH plus calcium hydroxide. Okay, how many hydrogens? 1 2 3 4. So you need 2 H2O molecules. Okay, then it is balanced. What is this? This is calcium carbide. What is this? Ethyne. And you're getting the calcium hydroxide. These kind of reactions where you are adding water and breaking the compound is called as hydrolysis. Like electrolysis, no? This is hydrolysis. Second one, dehydrohalogenation of 1,2-dibromoethane or ethylene dibromide. It is just the same way like what we did for alkene. Okay. What is this? 1,2-dibromoethane, you write 1 and 2. Dibromoethane. So one bromine here, another bromine here, one hydrogen, another hydrogen. This is 1,2-dibromoethane. What is the reagent we used? Potassium hydroxide. What is the condition? Alcoholic, hot and concentrated. Next, what's happening here? That's important. See, for this we need two molecules of KOH. One K plus will here, one K plus will come here, one OH minus will be here, one OH minus will be here. You need not to show all of this. What I told you, just to make you understand, I'm writing this. So this will take away H plus. K plus will take away Br minus. Okay. So two things are going simultaneously. A total 4 atoms. So there are two bonds, extra bonds should form between carbon and carbon. So that is a triple bond. So HC123CH plus 2 KBr plus 2H2O. So that's the balanced equation for the laboratory preparation of this ethyne. Okay, come to chemical properties. Alkenes and alkynes have exactly same chemical properties. They undergo addition reaction. Whatever hydrogenation, okay, catalytic hydrogenation, bromination, chlorination, same thing. Take the carbon triple bond, that is alkyne, that is ethyne, add hydrogen. See, if you add only one molecule of hydrogen, only one bond will be removed. So what will happen here? CH2 double bond, CH2 will form. So this is what? This is ethyne, this is ethene. So, but ethene also undergo hydrogenation. So, but what is the catalyst here? Nickel, right? Nickel catalyst. Same condition, 300 degrees Celsius. So same, nickel catalyst 300 degrees Celsius. So here you will get CH3, CH3. So complete hydrogenation of ethyne will give you finally ethane, right? Same way, chlorination and bromination. C triple bond CH plus, once you do chlorination in CCl4, you will get C double bond C, Cl and Cl, H and H will remain as such. Do one more time Cl2 in CCl4, C, Cl, Cl, H, single bond, Cl, Cl, H. Okay, now naming 1, 2, 1, 2, dichloro. What is this? The dichloroethene, ethene, right? This is what? 1, 1, 2, 2, tetrachloroethane, tetrachloroethane. Come to bromination, exactly same way. You will write C triple bond CH and H. Bromination CCl4. Okay, so C double bond C, one bromine here, another bromine here, hydrogen and hydrogen. This is what? 1, 2, dibromoethane, ethene. Okay, very important. Another bromination, another time. Okay, you will get C, C, Br, 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 H, H. This is what? 1, 1, 2, 2, dibromoethane. Okay, right. Last, sometimes these kind of questions are also asked, how you distinguish alkene, alkene, alkyne. Very important. I just gave you, complete the table with proper observation only. I have not given any equation. Okay, on adding few drops of bromine in carbon tetrachloride to what? To alkane, alkene and alkyne. Alkane, no changes observed. Alkyne, the reddish brown color gets decolorized. Same thing happens for alkene. What? The reddish brown color gets decolorized, because what is this reaction? Bromination, what we just studied, this is the same thing. Bromination of ethyne, bromination of ethene, right? So bromine in CCl4 is reddish brown. Once it gets added to the double or triple bond, it will become decolorized. But alkane has no unsaturation, so it will not change the color of bromine. So this is how we distinguish between alkane and alkene alkyne, or you can say saturated and unsaturated compounds. Now alkene is done. What about alkene and alkyne? How do you distinguish between them? For that we have two tests. On adding few drops of ammoniacal cuprous chloride, so same thing, no change is observed here. Alkene also will not show any change when you add ammoniacal cuprous chloride. Cuprous is CuCl, not CuCl2, that is cupric. Ammoniacal means they dissolve this in ammonia solution. Okay, ammonia solution. What happens here for alkyne? You will observe red precipitate formed. Okay, the copper will go and add across the carbon-carbon triple bond. It's called as copper alkylidene. Okay, but that's not important. Observation, red precipitate is formed. Same thing what happens when you add ammoniacal silver nitrate, AgCl in ammonia. Okay, no changes observed for alkene, no changes observed for alkene, but alkyne will show you white precipitate. So that's how you distinguish between alkene and alkyne using ammoniacal cuprous chloride or ammoniacal silver nitrate. Alkane and or saturated and unsaturated, have you distinguished bromine in CCl4 or sometimes bromine in water also. Okay, same observation. Okay, so this is all important chemical equations and some observations regarding the organic chemistry chapter. So around 15 marks will be asked in the exam, so this is very important chapter. So prepare well, practice this once again. Okay, so all the best for your exams. Take care, we'll meet in the next class. Bye bye.